This video is about pressure and volume relationships that we're going over in class on February 3rd and 4th. The gas law that describes pressure and volume relationships is Boyles Law. This is our one inversely proportional relationship that we're studying. So in 1662, English scientist Robert Boyle discovered that gas volume and pressure are inversely proportional at constant temperature. Notice that just like our other gas laws, something has to be held constant, meaning that doesn't change. In this case, it's temperature. But unlike our other gas laws that we've studied so far, this one is an inverse relationship. So for example, if the pressure is doubled, the volume is cut in half. Or if the volume is cut in half, the pressure is doubled. Or if the volume is tripled, then the pressure is cut in a third. Yes. So here is our equation for this one, or formula. It's different than the others we've used because this is an inverse relationship. So now this is pressure 1 and volume 1, and they're stuck together by multiplication rather than division. And then pressure 2, or pressure final, and volume final are, again, stuck together by multiplication. So when gas temperature is held constant, meaning it doesn't change, the following equation expresses the volume and pressure relationship. Just like our other gas laws, if any three of the variables in this equation are known, then the unknown fourth variable can be calculated. So here's a picture that shows this idea. Notice that the size of the containers are changing, that's the volume, and then also the amount of little weights required to hold the volume are changing, that's the pressure. Here is our first example problem. So this is our easy one that we're going to start with. We can use any pressure units and we can use any volume units. So that's easy. We don't have to worry about converting units. So pressure 1 is 100 atmospheres. Volume 1 is 100 liters equals pressure 2 is 20 atmospheres, and volume 2 is the one we don't know. So to solve for this, we want to get our unknown, which here in this case is volume 2, we want to get that by itself because we have 20 atmospheres stuck to it. Our pressure 2 is stuck to it by multiplication. We do the opposite of that to start to get this volume 2 by itself. So we're going to divide by 20 atmospheres on both sides because we always do all of our algebra the same on both sides of the equal sign. So that crosses out there. Notice that atmosphere crosses out, and now we can simplify just this left side of the equation and we'll figure out what V2 is. So on the right side, all we have is V2. The left side, we have to do 100 times 100 divided by 20. Or we could cross out one of the zeros first, so why don't we do that? So we can cross off a 0 and a 0. So now we have 100 times 10, that's 1,000. And then we divide that by 2, and we get 500. So our answer here is 500 liters. This is our units of volume. There we go. And then we just might want to double check to make sure that our change happened in the correct direction. So let's look at our two pressures. So pressure 1 was 100 and pressure 2 was 20. So that means that pressure went down. And because this is an inverse relationship, that means that volume should have gone up. And if we look at volume 1, it was 100 and our volume 2 is 500. So it did go up. So we know that we are doing the right thing. Great. Okay, here's example 2. A sample of gas occupies 523 milliliters. Milliliters are volume at 1 atmosphere. That's pressure. So the pressure is increased to 1.97 atmospheres while the temperature remains the same. What is the new volume? So here's our pressure 2, and it's asking what is the new volume. So V2 is what we don't know again. So let's start plugging in our information into our equation. So 1 atmosphere, 523 milliliters equals 1.97 atmospheres V2. Okay, so we're going to do the same thing as we did in the last one. We can notice first, though, that our pressure is going up. It's almost doubling. So our new volume, we should expect it to be about half of the initial volume because of our inverse relationship. So let's go ahead and divide by the 1.97 atmospheres on both sides of the equal sign. This is going to cross off there. We get V2 by itself, great. And then we can cross off atmosphere units, and then we're going to have to use our calculator here. And we go ahead and get 265.5. Oh, that's the wrong units. Hold on. Volume. Milliliters. There we go. 265.5 milliliters. And yeah, that's about half of 523. Great. So that is our answer. Example 3. A sample of gas occupies 100 liters at 2 atmosphere. The pressure is decreased to 760 millimeters of mercury. What's the new volume? Ooh, this is a tricky one because it's adding something new. Okay, so let's check this out. A sample of gas occupies 100 liters. Okay, liters are volume. So here's our V1. At 2 atmospheres. Okay, atmospheres are pressure. That's P1. The pressure is decreased to 760 millimeters of mercury. Well, that's pressure 2. What is the new volume? But there's something wrong here. We have pressure 1 and pressure 2, but they're actually in different units, and that's a problem. We need both of our pressure values to be in the same units. So we have to look back at our notes and find a conversion factor that will convert one of these into the other units. So if I look at my notes, I go back and find a chart that gives me that 1 atmosphere equals 760 millimeters of mercury. That's great because my pressure 2 is 760 millimeters of mercury. That means that I can easily convert the 760 millimeters of mercury that's in my problem into atmospheres, and in fact, it's just 1 atmosphere. So we don't even have to really do any math because it just matches our conversion factor. So I'm going to use pressure 2 as 1 atmosphere. So now I can set up my problem. So pressure 1 was 2 atmospheres times volume 1 is 100 liters. Pressure 2 is 1 atmosphere. And we don't know V2. All of our examples are solving for V2. Oh well. This is a really easy one because the only thing stuck to our volume 2 is 1 atmosphere. 1 times anything is just 1. So, but we can still, do the math, cross it off. So we're going to cancel 1 atmosphere. We're going to divide by 1 atmosphere over here. That's pretty easy. Atmospheres cancel. Okay, we know that if we divide by 1, we're just not going to really do anything. So we can just do 2 times 100. That's 200. Divided by 1 is still 200. Okay, so our answer, 200 liters equals V2. We can go ahead and check this to make sure it makes sense. So our pressure values that we have P1 and P2 goes from 2 to 1. That's dividing in half. And so that's going down. So that means our volume should go up. And in fact, it should double. So it should go up by the same factor that the pressure went down. And it does, because we started with 100 liters and now we have 200. 100 times 2 is 200. So we are good to go. And that's it for this lesson.